All right, hi everybody. In today's video, we're going to be taking a quick break from what we were doing before, where if you recall, we had this kind of like Sokoban-like experience going on where you could play a level and you could actually see what you've unlocked. But I do think there's still a little bit more work to be done in this regard, where basically if we're showing the number of moves and the seconds to beat, if I do a better job, so imagine like I'm on this level, right, where it took me a ton of time to beat it and I had a ton of moves, if I go back and I can do this, right? Shouldn't there be some kind of like congratulations or something for the user to see of like they actually did better than before? But we're going to leave that for a little bit and we're going to come back to it. And for now, we're going to be moving to something different, which is going to be using the command pattern to allow us to store the moves that a user made while playing the game. And then we're going to use that to allow the user to undo moves while playing. So if you recall, like in this level, if I do this, the level is now unbeatable. So imagine if I had, for example, the ability for the user to press U to undo previous actions rather than having to either quit and restart or press R and restart. So that's what we're going to be doing. For this first video, we're not actually going to be implementing the command pattern. We're just going to be implementing a linked list. So let's get started on that. I'm going to name it pooled linked list. And that's because we're going to be using something called an object pool, but we're not even going to get to the object pool in this video. We're just going to be implementing the basics of a linked list. So I'm going to name it pool node, and we're actually going to be using templates. And so a template is basically going to allow us to use this linked list for more than just commands. We're not going to use it for anything else in this project, so it's kind of a waste of time, but if you imagine for future projects, we may actually want to use a linked list, and then we could basically just take this and use it in a different project by just copying and pasting the code over. The other thing to consider is we could also just use STL's version of a linked list, which is totally valid, but I think part of the ethos, at least of these videos, is kind of trying to do everything by scratch, or at least within reason. So that's what we're going to be doing. So for the linked list, we have our type name, and all we really care about for a linked list kind of context, right? We have our pool node, and this is going to allow us, T star, like so. This is going to allow us to go forward through the list. We also need data, so we're going to have our data. Now, some of you are going to see this and going to say, why are we doing this by value rather than a reference or a pointer? And there's nothing saying we can't make this a reference or a pointer, right? Because it's just a template type T. Right? It could be anything. It could be we make like a pool node of type int star, for example, and that'll be valid. So we have that. Now we need to actually implement our constructor. Super easy. We just give a value, and then we just do next null pointer data value, and that's it. So that's our pool node. Pretty simple. Now we're going to actually implement our linked list. So it's going to take a type name of type T. We're going to have our pooled list type, linked list, right? And I'll get into where we can use the pool as we go ahead. But let's start with this variable std size T, which is the name type size. Then we need to include cstdef, something like that. Yep. And so some implementations, by the way, will, instead of doing this, we'll do like a lower score m underscore size, right? And then they can implement size t size const, right? And then they'll just return m underscore size. Maybe this is a more C++y way to do it, because if I want to get like the length of a vector, I'll call a size, but this is just us. So let's just do a size. And if someone wants to change this value, then that's on them for doing that. Next, we're going to be doing two things, which is if you're using like a typical implementation of a linked list, you'll probably see something like this. Pool node, type T, star, head, pool node, T, star, tail, right? And so this is for the front and this is for the back. I personally find head and tail just a little bit weird to read, is the way I'll phrase that. And so I think front and back is just a little bit less cumbersome to read, so that's what I'm going to make it. And now we can actually just get into implementing our linked list. So we'll do the constructor first. The size will be 0. The front will be a null pointer. And the back will also be a null pointer. There's nothing to actually implement, so we'll just keep going. In terms of the deconstructor, right, we got this. We're going to call a clear. And there's actually no definition of clear, so we're going to implement a definition of clear now. Pretty simple. So what we're going to do first, we'll set the size equal to 0. We won't need it for the deconstructor, but it just reduces our duplicate code, so we're okay with it for the most part. Now we actually want to do it. What we actually want to do now is we'll have a while head does not equal null pointer, or not head, sorry, front, and we're going to be using the front because we only have next, so that means we can only loop through this way, which is unfortunate, but okay. So now what we're going to do in terms of clearing is while head is not a null pointer, we're going to have our little temp. Let me actually put the temp up here. Pull node t star temp, right? So we say temp is equal to front. Simple enough. Well, not front. Front next, right? Then we delete front. Then we say front is equal to temp. So that's our deconstructor. So basically, as we're like looping through, if you could imagine like this, we get this one, we get the next one, then we delete the previous one, and so on and so forth. Right, so that's super simple. Now we can actually go into doing stuff. So let's start with two functions, which is basically how we're going to add stuff to the linked list. So first we'll do is, let's do void push front. So this is going to add things to the front of the linked list. So we have to have two things. So if front is equal to null pointer, right? That's our first case. Otherwise, that means there is something at the front and we have to move the front over one. So this is where using, for example, a vector array wouldn't be great, because instead of moving just one element over, we'd have to move every single element in the linked list over by one and then fill in the spot at the front. So what we're going to make is const pool node. I don't know if we can actually use a const, but I'll come back to it in a second. And n, or new node, let's say, is equal to new pool node of type t. And what we need is t data, right? So data, and we do this. Looks good so far. I don't think it's going to be, we'll just see. I don't think it can be a const. I put money on it. So this is front is equal to new node. Otherwise, front does exist, right? So we'll create a new, actually no, we'll just do new node next is equal to front, then front is equal to new node. And I think that's all we need to do for that one. Now we'll do pushback, t data, and none of these can be const, by the way. We're going to, again, just do this exactly. So let's just take it. And in this case, we want to see if back is equal to null pointer. There's actually a bug already in the code, by the way, fun fact. Because if front is a null pointer, then back is equal to a null pointer, which means back needs to be new node. So if back is equal to a null pointer, then what we want to do, this is actually just going to be the exact same. Perfect. And then in this case, right, this means there's multiple ones in the linked list, like multiple nodes in the linked list. Then what we want to do is we want to say back next is equal to new node, and then back equals new node. And that's it, because we just moved it over, and that's it. Yeah, and I think that's it. So that all looks pretty good. And I want to just take a second here and actually use it. So let's do a pooled linked list of type int, just for easiness, and we'll do I'll do is int, sorry, not size t, int I is equal to 0, I less than 10, plus plus I, right? ll.pushback, and we'll just do I. And then I'll do ll.push front -1. So that will be in order. And then what I'll do is I'll do pool node type int star temp equals ll dot, we'll do back, right? While temp does not equal null pointer, cout, and then it will be temp dot, not temp, temp data, and L, and then we need IO stream, and then we need temp is equal to temp next. I don't know if this is gonna work, but we do need to do that. Let's see if it compiles. That's our first test. No, it did not. So it's definitely the consts that were a problem. So let's remove the consts, if I understood those errors at a glance correctly. That was that. Good instinct for once. And you can see we printed out 9, and that was it. So let's see. ll.back should not be back. We want front. But that's actually kind of a good test anyways, because we see we got to the very end of the list, and that was it. So now if we run Sokoban, you can see everything worked, and even push front worked correctly. So that's looking good. But what we don't have is a way to remove anything from the list. So let's implement removing. Void remove front, t date. No, there's no data actually, sorry. Just that. And then we're also gonna do remove back. So let's start with remove front, then we'll get to remove back, and that will actually be the end of the video. Oh, there's one thing I didn't do. Sorry about that. Plus plus size, plus plus size. Cool. Now we can get into the other one where we're removing stuff from the linked list. So in the first case, we need to handle, we basically need to handle a couple things. So if like front equals null pointer, we're just gonna not make this a breaking error, but you totally could, and I think that would be valid. If back is a null pointer, we're also just gonna not throw it away. We're not gonna like force the program to end, but I do think that's a valid implementation choice. So in either case, we're gonna do a minus size, right? Because we're removing 1. You could also do if size is equal to 0, and that would also work. Assuming this is right, but I think this kind of style is just a little bit safer overall, so it's what I would recommend. Okay, so now basically what we want to do is we want to, in this case, get the front, change the front, and then delete it. So what we can do is we can say pool node t star temp is equal to front is equal to front next, right? And then what we can do is we can do delete and then temp. And that is everything we need to do. Is there anything else before I remove front? Yeah. So this is where we get into something that I hadn't thought about when I was initially just going through this in my head and kind of just like implementing it just really briefly just to make sure I'm not crazy, which is in the tail case where we're removing the back, what's gonna happen? And actually when I think about it, we're almost okay But let me just show you. So say we're removing back, so we're gonna get rid of this one. The question is, we don't have access to this one, this node easily, because this is gonna be where the new back pointer should be. So we, in a sense, just have to loop through the entire thing to be able to do anything, which I personally don't love. I think that's kind of bad design. And so the question is, how do we handle it? And what I'm going to do is I'm going to do pool node t star, and I'm going to name it previous, actually, now that I think about it. And I'm going to name it previous instead of, for example, prev. Based on this talk I heard DHH, it was an interview actually between DHH, I don't know what his full name actually is, it's like David something, but you know, he did Ruby on Rails, and he recently did like Omarchy, I think it was, and he was in an interview with Lex Friedman, and he was talking about Ruby versus Python. And he was basically talking about Python's kind of gross to look at because you have these two underscores and then you have init. And then Ruby, you just do def initialize. And technically, you could do something like init rather than initialize. But there's something, from the way I see it at the very least, I don't know exactly what DHH's point was off the top of my head at this point because it's been a bit. But I like the idea of this because it almost reduces the cognitive load on the user because you have to take this shortened version of init, expand it to initialize, and then kind of work through your head what that even means. Whereas in this one, it's just right there, initialize. So that's why I'm doing previous instead of prev. I don't know if I'm going to stick to this kind of style of like longer variable names, but it's kind of interesting. So we have our pool node. We've added this previous, which actually means our initialization of these ones over here need to be updated. But before we do that, let's actually do some work over on these two functions, and then we'll come back. So in remove front, right, we have the first one. That means the previous pointer is always going to be null regardless, so we don't actually have to worry about it. And in the other case, right, what we do, pool node t star temp is equal to back, right? Back is equal to back previous, then delete back, or not back, temp. And you can see all of a sudden like our like this whole thing has gotten a lot more efficient just because we don't have to iterate through every time to delete something all the way at the back of the linked list. Now, if we want to delete something in the middle of the list, we have to loop one way or the other way to find it. But there's no way around that. So that is how this is going to work. It's probably, we do have the extra overhead of this like one extra pointer per list, but I feel like the trade-off is probably worth it. So we have back and previous, we fixed this. We don't have to worry about next because we can be explicit, I guess. Next equals null pointer just in case. But we don't actually need it because we deleted. Because remember, the next is this, and this was just deleted. So I'm actually not going to do back next is equal to null pointer because it's already kind of implicit within the code. And that means we have to go back to these ones. So let's first, before we actually do it, ll remove front, remove back. We'll do it like this, so it's kind of like weirdly ordered. And we'll do it like that. And then we'll also do this, but instead of temp, well, we're going to keep it temp, sorry. We're going to do back, and we're going to put these in between these two. And then I'm going to add a nice little C out just for us so we can kind of see things. And then we'll print it out again. But this time, instead of doing next, we're going to do previous. Okay. So now, before we actually try to run that, let's fix our push front and push back. So if it's null pointer, that's totally fine by me. For pushing it to the front, and then, so new node next equals front, and previous is always going to be a null pointer in this case, because we're pushing it to the front. So there's nothing that can be to the left of it. So I'm okay with that, I think. In the case of push back, let me think. The problem is, but front, we need to set the front previous is equal to new node. Yeah, because we push this one kind of like over, and then we're putting one right here. So we need to like link back. And so in this case, back next is equal to new node dot, not dot, arrow, previous is equal to back. And I think that's it. I think. Fingers crossed. We compile, we segfault. But we can figure out where we segfaulted in just a second. So you can see when we were pushing things, everything worked. But then we ran into an issue at some point. So let's go into main C++ where we remove front. So that's going to be 9. And we remove front over here, and that's 8. So that worked. We removed back. So that's over here. So we removed -1 and 0, but we didn't remove 0. Okay. So let's look at this logic real quick to make sure nothing's crazy. All right, and we're back. That took way longer than I thought it should. But basically, I did some changing of like the ordering. So like I just put in a temporary variable and all that. And then so like temporary back is equal to back, right? Back is equal to back previous. And then it turns out, even though I didn't think I had to do this, I did have to actually do this. So now in this extra like thing, basically like if I don't have this right here, and I make it, and then we run it, you can see like we get this extra 0 when we print out. And that was kind of my clue that something was wrong here, where it wasn't actually a null pointer, maybe it was something else. So that's how I fixed that. Remove front. Front previous is equal to null pointer. So now in theory, when I go back to here, I'm just gonna actually do this one step at a time, because now I do that, everything's fine. Oh yeah, in the deconstructor, I added a deletion little print right here, where it says like del, and then the data, which was the other tip. So now I make the whole thing where I'm testing remove front and remove back, and everything's working out. I also changed the size, so let's go back to size 10, so it's a little bit more clear. Right, so we deleted 2, 3, 4, 5, 6, 7 when we were doing the deconstructor. You can see it here, it went 0 to 9, and everything looks good. The only thing we're not testing right now is push front. So now let's make that and see if that works. And if that works, then we are good to go. So we have -1 at the start, then we lose -1 by the end, and you can see it was 1 bigger than before where we started del 2, now we're at del 1. So now we can remove that print. I don't think there's any other prints in here. Cout. No, not this one. Cout. Yeah, there's no interest. There's no like prints here. So this is our linked list. Wherever we're calling delete is where we're going to start using our game object pool. So instead of deleting it, what we're going to do is we're going to place it back into our object pool. So that way, when we're over here and we're actually getting pooled nodes, what we're going to do is we're actually going to we're going to go to our object pool and request a pool node. If a pool node doesn't exist, it will create a new one. But if it does exist, but if there is one that does exist, then rather than creating a whole new one, what it will do is it will return one that's already been allocated to the heap. So that's for the next video. We've done linked lists. We've had one pretty obnoxious little typo bug right here with these null pointers, but we fixed that, and now everything's looking pretty good to go into the command pattern where we implement undoing, and then also to do object pooling. What we'll do in the next one is we'll actually do the command pattern, and then in the final video, we'll get into object pooling, and then we'll get back to finishing the game. So yeah, I hope you enjoyed this one, and I hope you have a great day. Bye.